Definition of derivative. F prime of x means the derivative of f of x equals, by definition, the limit of f of x plus h minus f of x all over h as h approaches 0. The h in this definition means delta x, which is the change in x. Here's another definition. We say f prime of a, or the derivative of f at x equals a, equals the limit of f of x minus f of a all over x minus a, where x is approaching a. The word differentiate means find the derivative. Pause the video so that you can write all of this down. Some things we use the derivative for. F prime of a is the slope of the tangent line to f of x at the point a comma f of a. Also, f prime of a is the instantaneous rate of change of f of x with respect to x at x equals a. And these are different ways we symbolize the derivative. This is the notation. F prime of x, or we use y prime, or we often write dy over dx. When we write dy over dx, we say the derivative of y with respect to x. And this one is read the derivative of f of x with respect to x. When dx is on the bottom, we say the words with respect to x. Here's the first important example. If f of x equals 3x squared minus 10x plus 5, we're going to do these three things. We're going to find f prime of x, which means we're going to find the derivative of this function. And then we're going to answer part B. We're going to find the slope of the tangent line to f of x at the point 2, -3. And then we'll find a point on f of x at which the tangent line is horizontal. So to answer part A, this function is given, f of x equals 3x squared minus 10x plus 5. We start answering part A by writing the definition of the derivative. F prime of x equals the limit of f of x plus h minus f of x all over h as h approaches 0. The blue in this definition simply means the given function. The red means the given function with x plus h in place of x. So this is important enough for me to write this down. This red, f of x plus h, means the given function with x plus h in place of x. In other words, instead of x being squared, x plus h will be squared. Instead of -10 times x, it's going to be -10 times x plus h. F prime of x equals the limit as h approaches 0. All of this red is what I just said. It's 3, there's the 3. Instead of x squared, it's x plus h squared. Instead of -10 times x, it's -10 times x plus h. Plus 5 is still there. And there, the minus is part of this definition. It's right there. And this blue is just f of x. The blue is the given function. And now we just do a lot of algebra. The x plus h gets squared we get this trinomial, x squared plus 2xh plus h squared. The negative 10 gets distributed, negative 10 times x, and negative 10 times h is right here. Negative 10x minus 10h plus 5 gets copied. This minus, that's part of the definition, gets distributed. We get minus 3x squared minus a minus, so that's plus 10x minus a positive 5 becomes negative 5. Then we're going to distribute this 3. This red 3 is going to distribute. 3 times x squared is 3x squared. 3 times 2xh is 6xh. 3 times h squared is 3h squared. We also notice that we have a minus 10x and a plus 10x, which are not here anymore, and a plus 5 and a minus 5 is 0, so those aren't here anymore. We still have minus 10h and minus 3x squared. And here we notice 3x squared minus 3x squared. So they are gone. Then all these terms remaining have a common factor. H is in every term. So the h that's in every term gets factored out. We now have f prime of x equals the limit as h approaches 0 of h times 6x plus 3h minus 10 all over h. So h divided by h is 1. F prime of x equals the limit of 6x plus 3h minus 10 as h approaches 0. And we evaluate this limit by replacing h right there with 0. H is approaching 0. The limit symbol is not here anymore. F prime of x equals 6x plus 3 times 0 minus 10. So f prime of x equals 6x minus 10. If I went through that too quickly, make sure you pause the video and write all of this down slowly. So part B was to find the slope of the tangent line to f of x at 2, negative 3. So we say for this function that's given, we just answered part A, we found f prime of x. When we replace x with 2, we're finding the slope of the tangent line at the point where x is 2. 6 times 2 minus 10 is 2. This is the answer to part B. And part C asked for the point on the function where the tangent line is horizontal. And a tangent line is horizontal when its slope is 0. The derivative is the slope. We're answering part C by setting the slope of the tangent line equal to 0, because any line is horizontal when its slope is 0. The derivative is the slope of the tangent line. So we have 6x minus 10 equals 0. We add 10 to both sides, divide both sides by 6, and we get x equals 5/3. When x is 5/3, f of 5/3 is 3 times 5/3 squared minus 10 times 5/3 plus 5, which you can calculate to be negative 10/3. So the tangent line to this given function is horizontal when x is 5/3, and when x is 5/3, y is negative 10/3. And here's a picture to show what we did for part A. This blue parabola is f of x equals 3x squared minus 10x plus 5. This red line has a slope of 2, and it's the tangent line to the blue parabola at x equals 2, or at the point 2, negative 3. Here's a picture of part B. Actually, this is a picture of part B. Here's a picture of part C. On this parabola, at this point that we just found, that's the point on the function where the tangent line, which is this red line, is horizontal. Because that's where the derivative is equal to 0. The tangent line is horizontal when its slope is 0. Question, when does f prime of a not exist? And these are 3 instances when the derivative of a function does not exist. Number 1 is when the limit of f prime of x as x approaches a from the left is not equal to the limit of f prime of x as x approaches a from the right. Number 2, if the limit of f prime of x as x approaches a is either infinity or negative infinity. And number 3, if the original function is not continuous at x equals a. These are 3 instances when the derivative does not exist. Look at quickly an example of each. For this function, which is ordinarily written f of x equals the absolute value of x minus 4, the derivative of this function, because the derivative means the slope, this absolute value graph is linear. It's a V shape, but each side is a line, or part of a line. The derivative means the slope. The slope on the left side here, up to x equals 4, the derivative or slope is negative 1. That's if x is less than 4. But the rest of this has a slope of positive 1. That's when x is greater than 4. But the derivative right at 4 does not exist because the limit of the derivative, which is up here, as x approaches 4 from the left, is not the same as the limit of the derivative as x approaches 4 from the right. On the left side of 4, the derivative is negative 1. On the right side of 4, the derivative is 1, and those are not equal. We say that when a function has a sharp turn, there will not be a derivative. There will not be a derivative at the turn. The sharp turn, some people call it a corner. So I'll just reiterate. For example, if x is 3.9999, the derivative is negative 1. Because when I say the derivative, I mean the slope. But if x is 4.0001, the derivative is 1. As we zoom in, close in on 4, the slope on each side is always -1, no matter how close we get to 4 on that side, and always +1, no matter how close we get to 4 on that side. So we're going to say the derivative at 4 does not exist. We also say the words this function is not differentiable at x equals 4. And for this function, which is a semicircle, f prime of 5 does not exist. And f prime of -5 also does not exist. And they're both because if we were to draw a tangent line at x equals 5, it would have to be a vertical tangent line. Same at -5. If we were to draw a tangent line at x equals -5, it would be a vertical tangent line. And the slope of any vertical line does not exist. The slope of a vertical line does not exist. So the derivative, which is the slope of a tangent line, would not exist for this function, but only at 5 or at -5. It would be possible to draw a tangent line with slope at any other point on the blue curve. All right, and the last example is this function, f of x equals the absolute value of x minus 3 over x minus 3. If we find the derivative of this, this part of the function has a slope of 0. That's if x is less than 3. And this part of the function also has a slope of 0. That's if x is greater than 3. But the derivative of this function right exactly at 3 does not exist because the function itself does not exist at x equals 3. We can't find the derivative at 3 if the function itself is not continuous at x equals 3. This blue function is not continuous at x equals 3, so it can't have a derivative at x equals 3. If a function is differentiable, meaning possible to find the derivative at x equals a, then that function is continuous at x equals a. And we just showed in the last example, when a function is not continuous at x equals a, then it is not differentiable at x equals a. And when you come to class, we're going to do this example. You might see if you can do it ahead of time on your own. If f of x equals the square root of x, then f prime of x, that means the derivative of this function is 1 over 2 radical x.